Welcome back to World of Technology. In the previous video, we learned Kubernetes architecture and understood that Kubernetes is made of control plane and worker nodes. But today, we are going deeper because understanding Kubernetes architecture is good, but understanding the control plane is where Kubernetes actually starts making sense. Questions like who receives Kubernetes requests, who decides where pods runs, who remembers cluster information, who fixes failures automatically. This is exactly what the control plane does. Think of control plane as the management center of Kubernetes. Worker nodes execute the work, but the control plane thinks, plans, decides, monitors, and maintains everything. By the end of this video, you will understand how Kubernetes turns a simple command into a running application. So let's begin. Let's start with the most important question. What actually is the Kubernetes control plane? The control plane is the central management layer of Kubernetes. It does not run applications. Instead, it controls the cluster. Its job is to continuously watch the environment, make decisions, maintain the desired state, and instruct worker nodes what to do. Think of it like an airport control tower. Airplanes do the flying, but the control tower decides where everything should move. Similarly, pods run on a worker nodes, but the control plane decides how everything should operate. Without the control plane, Kubernetes would simply become a group of disconnected servers. Now let's meet the first control plane component, the API server. The API server is the front door of Kubernetes. Every action starts here. Whenever you run kubectl apply, kubectl get pods, or any deployment request, the request first reaches the API server. The API server performs several responsibilities. First, it authenticates and validates requests. Then, it communicates with other control plane components. It acts as the central communication hub. Nothing enters Kubernetes directly. Everything goes through the API server. You can think of it as the receptionist or a security guard or traffic controller of the entire cluster. Once the API server accepts a request, the next important component is etcd. etcd is the memory of Kubernetes. It stores the complete state of the cluster. This includes pods, nodes, services, configurations, secrets, and desired state information. Imagine you deploy 3 pods. That desired state gets stored inside etcd. Now imagine one pod disappears. Kubernetes compares the current state with the desired state stored in etcd. Then Kubernetes takes action. That's why etcd is extremely important. If etcd is unavailable, the cluster loses its source of truth. Simply put, etcd remembers what Kubernetes should look like. Now comes one of the smartest component, the scheduler. When a new pod needs to run, Kubernetes must decide which worker node should host it. The scheduler makes this decision, but it doesn't choose randomly. It checks available CPU, available memory, node health, constraints, policies, and placement rules. Then it selects the most suitable node. Think of it like assigning hotel rooms. You don't place guests randomly. You choose based on availability and requirements. That's exactly what scheduler does. It ensures applications run efficiently. Now we reach the automation engine of Kubernetes, the control manager. This component continuously watches the cluster. Its job is simple. Compare what should happen with what is actually happening. For example, you requested 3 pods, but currently only 2 are running. Controller manager detects the difference. Immediately it takes corrective action. It creates another pod. If a node fails, it reacts. If application drift, it restore balance. This process is called maintaining the desired state. Controller manager is why Kubernetes feels self-healing. It never stops watching. Now let's connect everything together. Imagine you deploy an application. First, your request reaches the API server. The API server validates the request. Next, the desired state gets stored inside etcd. After that, the scheduler selects the best worker node. Then, Kubernetes on that node creates the pod. Finally, controller manager continuously monitors this cluster and ensures everything remains healthy. So the complete flow becomes user to API server to etcd, etcd to scheduler, scheduler to worker node, and worker node to controller monitoring. This entire process happens automatically, often in seconds, and this is the real magic of Kubernetes. So today we went deeper into Kubernetes and understood what the control plane actually is, how API server receives requests, how etcd remembers cluster information, how scheduler chooses nodes, and how controller manager keeps everything healthy. If Kubernetes architecture showed you the map, then today's video showed you the engine. Once this control plane concept becomes clear, many advanced topics like pods, deployments, networking or scaling and troubleshooting becomes much easier. In the next video, we will continue opening Kubernetes layer by layer. If you found this helpful, subscribe to World of Technology and continue your Kubernetes and CKA journey with us. Thank you for watching, and I'll see you in the next video.